shop lit where the circuits gleam. AL's got the tools, living the dream. Some things blow up, oh yeah, it's true. But it's all part of the fun when I'm sharing with you. Amp it up, let the music flow. AL's got the magic, come and see the show. Experimenting with wires, making sound divine. When things blow up, we just laugh, that's fine.
Greetings, the Astro 30 here yet again. Welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thank you very much. Sitting on the desk here, I've got about $92 worth of hardware, which is quite expensive. But today we're going to be finishing off the NE5534 stereo bench test amplifier, and I've got all the parts now I need to do it except the transformer, which is on order and will arrive tomorrow. So by the end of the video I should have a complete project. So I'm just going to go through here quickly what I've got. I've got this black equipment knob, which is JCar Catalog HK7766, and one of these like style of knobs that have been used on a lot of home built projects for years. There's various different sizes. I've got a 3-pin power plug with the safety protection, which is mandatory now. It's a PowerTech brand. Catalog PS4110. They're about $9.95 each. And the equipment enclosure, which is HB5556, and they are $79.95. And I've used one of these before when I built that power supply unit, and that was a very long time ago. So I'll just open the box so we can have a look at what I have got. And I have no idea why I am speaking like I am a Frenchman. How am I going to do this? I don't remember these coming in a box though. Maybe they did. Right, so we've got both the rear and the front panels wrapped together. We've got the 4 screws for the top and bottom panels. Got supplied rubber feet, which I've gone and bought some feet, and I can't use them now because, well, I don't need them. I'll use them for something else, that's fine. The instruction manual of how to assemble it. It's not that complicated. It just basically shows you an exploded diagram of the casing and how it goes back together. It's not that hard to figure out. Plastic gives you the bill of materials, like how many covers there are, etc. So that's not really useful to me. Here is the one on the top or bottom panel, it doesn't matter which one. I banged the tripod, I am sorry. There's the side frames, and finally another cover. So there we go there. I've also gone ahead of time, when my off time when I was bored, gone around and measured hole centers between PCB mounting holes, etc., including the heatsink bracket and the power amp modules. Ignore that because I measured the wrong one. So that's my switch fuse board, which goes on the back panel. So I've got 42.5mm across that way between those two centers and 21.5 between those two centers. The power supply unit itself, 52.5 between those two hole centers and 87 between them. And the measurements for the actual power amp itself. Now those standoff points on the PCB itself, they work out to roughly 50.5mm between these 2 points, which is okay. So this is a lot easier to just measure it, mark it out, on a bit of paper before drilling so I can actually measure it properly rather than drawing around holes in things, which I have been well renowned to do in the past. And this is my basic internal layout, which is not to scale, but it just gives me a basic idea of where everything's going to go, like the power amp modules, the power supply and what orientation it is, including the vented area, which I thought I was going to like mount it at the back, but considering how many holes, like where it's located on the panel, how wide it is, I think I will leave it at the front. But yeah, I'll figure that out as I go. I've got the transformer drawn as a square. It's a toroidal, but I'm using that to keep the 90mm of area free, so I know that that's where the transformer has to go. I can still drill the pilot hole for the bolt, but I'll wait until I've got the transformer to actually measure the bolt diameter. So next thing I'm going to do is I'm going to lay the PCBs in the panel of the case just to see how things are going to be mounted with respect to the physical panel and how it relates to this. So that's the next step. Right, so this is probably going to be a long video, so get your popcorn ready. Right, so here are the PCBs. So it's a little more awkward with other interconnecting PCBs connected. This is my volume control board. I'm probably going to put a preamp in it later, so it's just a simple board with 2 capacitors and 3 connectors on it. There is probably going to be just enough room in here. This AC board's starting to piss me off. Yeah, there's going to be just enough room in there, I reckon. Transformer sitting over here, power supply sitting in that orientation, go away. And I'll just make sure that the power amps are mounted well over to the side of the case here, keeping in mind that I've got to include these panels, so they may overlap. Well, the way they go is like that and that. So there is going to be a slight overlap sticking out into the case. But I reckon if everything was jammed up against each other it would still fit, because I don't think there's going to be any room to mount the supply down that side. Because I also got to leave, no there's not, I've also got to leave room at the back here for the front and rear panels to guide into these holes. So I'll deal with that in a sec. I just want to see if I'm going to have, it's really, you wouldn't believe how difficult it is to work around a tripod. Yeah, that's going to be awfully close. Get that out of the way. I'm going to now, for now, just remove these joins. So these modules are separated from the wiring, so I can maneuver stuff around. Okay. Because that's going to be awfully, awfully tight. So I'm just wondering if there's now enough space for the transformer to fit in there. Because I need 90mm. Take that side panel off. Just. I don't think it's going to make any difference if I turn this module around. It might do, because I think it's not as long as it is wide. Yeah, I can always mount it like that. That'd work too. Yeah, I think I'll go with that way instead, because that'll give me enough room over here for the transformer. That should give me now about 110mm, I reckon. So almost 110. Okay, so that sort of like worked that out. So my original plan didn't work out the way I wanted it to, but it rarely ever does. So I can bring that over to here. So what I might do is I might drill the holes for the power amp first, so then I can work out where the power supply is going to go. So the width of this from the inside edge, well actually probably from the outside edge would be better, is 15 mil. So I've got to leave 15 mil from the edge, maybe 16, just to clear the edge of the bracket here, before I come to the centres of the hole. So, or the holes. So I need to know what the measurement between my tapped hole and the outside of the heatsink bracket is. About 26 mil. So that's 26 mil plus 16 is 42. Yeah, so it comes in 42 from the edge. Alright, I'm going to get started doing that, and I'll work out where this is going to mount from the back. I'm going to say, we'll make it 50 mil, that should be plenty. Alright, let me get started doing that. Well, that's the power amp mounted, about half an hour of farting around later. I thought I'd messed up with my measurements, because that is really close to this edge. It's only like probably 12 mil, and I'm thinking, oh, does this fit on? Go to put it in. No, it doesn't. Oh no. Then I realised, well, it actually sits here. So it just sits on top of this bracket. So there's like a 5 mil gap between this lip and the inside of the case. So, phew. Otherwise that would have been a real bastard. As long as it clips into the side clips over here, that's fine. So once the screw goes in, no problem. There's all about probably a half a mil gap between the heatsink bracket and this lip. Okay, so that's the power amp module mounted, and I had my measurements off. It was 27 between the hole centre here and here, not 22. Don't know where I got 22 from. Right, so next it's to mount its companion, the power supply, which for visual purposes I might just mount like that. If I do that, however, it may be my DC connections are too long now. Oh, I can always unsolder them from the board and shorten them, I guess. Just means removing each power amp module to do so. So I'll get rid of that one. And that gives me a good 110 millimeters, so I'll make sure that the transformer will sit inside that measurement. So I need to know from the side of the case. So if we come in 20 from this side, and then come in 45, which makes it 55. That should be where the center of the transformer hole goes. But what I'll do first is I'll work out where the power supply is going to mount, and I'm just hoping that lead on my power switch is now long enough for the LED, because that's going to be mounted all the way over here. And yeah, that lead is nowhere near long enough. Of course it's not. Alright, I'll have to redo that, but that's fine. I'll just use a new connector and some new wire. Probably should have waited to do that till last. Alright, doesn't matter. Okay, so then we're going to have the AC coming in here. Yeah. Doesn't really much of a muchness. Alright, so I will mount it that way. that's the power supply mounted. I thought there was a bit of a twist in it. Well, there is a slight twist in it. That's alright, the panels will pull it flush again. It sort of ended up somewhere in outer space. Yeah, there's a bit of an overlap here and here. I didn't mean to do that, I meant it to be flush, but well, it's actually now in line with the heatsink bracket, but anyway. Okay, so that's progress with a capital P. No idea what that's supposed to mean, but yeah. Okay, so I'm going to put a bit of tape. Probably a bit too much tape. Roughly where the transformer center point is going to go. So I'm going to mount that pretty well backwards in the case anyway. Alright, so what I mean is, I'll grab the panel because there is a lip overhang. So in actual fact, it sits on the inside, so you've got a about 15 mil I think it is from here to here, but you're losing there plus 15, so we've been all looking at about 20 millimeters of loss from there. So that would be my base point, I reckon, is 20 mil. Oh, easily 20 mil. Okay, so I know that the center point of the transformer can't come 45 from there because it won't be correct. So that'll make it 65 if you add the 20. So I'm going to do the right thing, lose my pen. I'm going to start at 75 for the center, which should, if you go 45 that way, 45 that way, 45 that way, which is off there somewhere. I'll put a bit of extra tape there just so I can visualize this in my own head. So we're going 45 that way, which means I need to go 45 that way. So if I put the center point, and I'm guessing the distance here, I'm using the vents as a guide here to get my ruler straight. Okay, so that's going to be the line the transformer mounts on. So we have 53 that way. It will be 53 that way as well, thereabouts. And I've got 71 or something from the edge of the case, so that should clear the side panel if it was on. That gives me 55, 56, something like that from this edge, which is perfect. So the transformer will just fit in there, as long as Ultronic's measurements are correct. So basically, that's where I'm going to drill the hole, is at that center point. But I also need a ground connection, so I might put the ground up here somewhere. So I'll put another bit of tape. There. That's got to clear the transformer, so I might put that roughly in the center of that. So if I come in line with this bolt, I should be pretty fine there. So it doesn't have to be accurate. So I need to come in at least 35 mil to clear the lip at the front here. So that's 35, puts that roughly about there. So that's going to be my ground point. So I can go ahead Hope this is right. Commit to this. Mark the holes. And yes, I'm going to be drilling with the modules mounted because I'm dangerous like that. Very, very good. And if that hole is in the wrong place, I can always move it and just leave the hole there, it's fine. Just doing a little bit of deburring there so we don't have any like sticky uppy crap, even though that hole's got to be enlarged. Right, so I might as well put my ground stake in. I'm going to use a 10mm M4, I think that should be long enough for this purpose, I don't think it needs to be any longer than that. And now I have to do him up once I find my pliers. Yeah, that should be plenty long enough. Fail. No damage. I did scrape the inside of the case with the pliers though, but that's fine. So that ground will reach there. These two grounds will reach fine. I am probably going to shorten the power supply leads because they're way too long, and most likely shorten these, and that's easy enough to do by just unsoldering it from the board, redoing it, because they've got to go like here, so it's going to be like all this wire sticking up. That's pretty much what's going to do it for me today, because it's starting to get late in the day and I've got to do other things this afternoon. Well, it's only 11:30 I suppose. I might work on getting the front drilled first. It's just a power switch and the RCA sockets and the volume board. So speaking of which, these are the audio leads that have to go to the volume board. So I think these are going to be way too short now. So these go into here. No, maybe they're the other end. Okay, so it must be this end. Yep, they're way too short. They're not going to reach the front. Because it was originally designed for the board to be orientated that way. However, one's long enough. I'll just have to lengthen this one, so I'll have to make a new cable up for this. I'll keep this cable all crimped together with its, well, I've got plenty of crimp pins, I might just steal the housings. I'll just remake the cable. I believe I've still got some of this length lying around. I'll have a look in a second. But this one should fit the board. I can find where the left one is. Sorry, the right one. It's that one. Yeah, that'll fit just nicely. Okay, cool. So I have to lengthen the wires for the LED. I have to lengthen the cable for the left channel. That's fine. That should be long enough. Okay, so I'll move on to doing the front panel and I'll worry about cabling a little bit later. I'll have a look around, see what I did with the rest of this cable, see if I've got a long enough piece. Yep, I do. I've got like about half a metre here, so I could always redo both, but I'll just redo one, because what's the point of redoing both? It means I have a little bit of red wire, centered wire left over, which I haven't used, but you know, this stuff is relatively cheap per metre. It's only like, I think, about $1 or something, $1.20 or something per metre. It's easy enough to get some more. Alright, that solves that problem. moving on to the front. So I got the front panel marked, power, input, left, right, and the volume control. This is going to be a bit harder to drill because of there's this, you know, lip in here that I can't get my, well, at least I don't think my drilling board's going to fit in. Oh, it will just fit, it's just that it's still got a little like lip at the top here, so that's not going to be very handy for me. So I'll just have to drill it straight like that, I guess. I've got not much choice in the matter there. And when I hit this with the hammer, I don't want it to bend. So I probably could have done it on the inside, but yeah, I can't think of anything else I can prop in there temporarily to prop that up. No, nothing. Okay, so I'm just going to have to go with it. I hope I don't bend it. Which it sort of did. Not by much. Maybe if I do it on a flat, that might work a little bit better. I don't have to hit it that hard anyway. It's just enough to mar the, or dent the surface. A little bit more for that one. I need to mark out my stake, where this thing sticks out, so I can drill a hole for that as well. I believe that's just 7mm from the centre. Yeah, 7.5. About 8. 8 should be right. So I'll mark across 8mm, which is there. And I'll put another divot in the thing. There. Okay, and then I can drill these holes. I decided to show you this process because this is the annoying part, is deburring holes properly. So, yeah. Okay, now I need to drill the hole for the pot, which I haven't done yet. Four. 6. 8. Right. Okay. Right, so that should fit the pot now. I need to deburr this locator pin, but I'll take the nut off and washer off of the pot. And being an 8mm hole when it's supposed to be around about a 6.5, I think it is, gives me massage room to get the dowel pin to line up. Oh, that's perfect. Yeah, perfect. That works out nice. There we go there. Nice. There's plenty of wiggle room in there. That's great. Okay, so now I have to drill the power switch hole out, but I can't remember the size of the hole, like what diameter it is. So, gonna get some calipers and zero it. Uh, 19.4, something like that. So I'm going to say 20mm, which is the max of my current stepper bit, but I do have a set that I got from Temu, which I'll probably use them. So I'll go up to probably the 16mm mark on this one. So you should really clamp when doing stuff like this. 4, 6, 8, 10, 12, 14, 16. See that it can get quite violent on you. So I'm going to take this step a bit out, and I'm going to go grab the Temu ones. This big heavy one, this is imperial, not metric. So it barely fits in my chuck. And that's the wrong way, idiot. Let's try that again. So I know I was at 16. Wow. That's blunt as fuck. These that I bought from Temu are absolutely bloody useless. Bloody useless. Even though I just got through it. I hope that's the right size hole. Because I don't want to have to deal with those again. So I'm probably never going to use these piece of junk Temu stepper bits ever again. I'll go to Bunnings, pay the 30 bucks and get a proper one. Now we should be up for off and down for on. Currently there's no continuity because, well, it's up, so it is off. Now it is on. Off, on. Excellent. Okay, cool. So that's the power switch mounted. I'll put a little bit of hot glue around this. These wires are about to break anyway. I've got to change them, as I said, to longer ones. I don't think I debooted that. I don't remember doing so. I have now. I can put in the RCA sockets, but I've got to unsolder the wiring to them so I can put them in. So I'll do that now, and then I'll come back when I've actually got something more complete. Rightio, it's starting to look like something. There it is there. You may be asking a very important question. Why did you put the RCA sockets on the front? Even though visually, vertically they're out of alignment, but anyway. Because to make quick, easy access for plugging in and unplugging audio leads. And this volume board still wants to go crooked for whatever reason. I think because my pothole is a little bit larger than it needs to be, makes it, getting it where I want it, that's about right, a little harder. So next I'm going to put a little bit of this tin copper wire between the two posts here so I can make the ground connection. I hope you're enjoying this video. I know it's probably going to be one of my longest ones, just pissing about building a test amp, but it's fun for me. I'll try and make this a little bit more concise in editing as best as I can, but I can't guarantee any promises. I should say I can't make any promises. Right, so I'm going to solder in this wire for the right hand channel, passing it through the eyelet. Okay. Might give that a bit more of a tin. Perfect. The same on this. Unplug it from the board might make it easier to do. Indeed, and I want that ground to point off to where ground is. So, solder this one through the hole. Excellent. Now trim the boobs. Okay, excellent. And I'll just add a dab of, I was going to say silicone, dab of solder on the centre of that, which just fell off. Then I can make ground connection. That should be perfect. Alrighty then, so get these solder balls out of here. That can now plug back into, take that one out, don't need it at the moment. That can plug back into the input, and then that can be just bent and fashioned that way so it's a little bit neater. And there we go. So whilst I'm at it, I might remove these wires from the LED because, well, they're too short anyway. Excellent. Alright, so one switch, and then when the knob goes on, which I need to undo the screw, so I need to find a screwdriver for that. There, like I bought one. Nice. Nice little knob. Okay, let's see if this just slips on the top, which it should. Excellent. I've pretty much finished drilling the panel. I mean, drilling this hole out's easy enough to do. So I'm going to put the rubber feet on now. Also, you really shouldn't be drilling into the bottom like this. There is rails provided on the side points there, so you can actually mount a plate or something to mount all your hardware to, but it's just as easy to drill into it. I mean, it's only for this purpose. Like, does it matter? No. Is it a good idea to do it the other way? Yes. But it involves more work. So you've got to look at it in two ways. Is it going to be easier to do it this way because there's less work involved? Or if you want to be more professional, do it the right way and use a floating panel. I would take doing the less work, like most Australians would. Alright, so there's the feet on. There's still stuff rolling out on the inside, but that's fine. Nice. Ah, it's like a thing of beauty. Well, not really. But it looks functional, and it will be functional. Volume. I've got a preamp board underway being made for this, but I'm going to, still weigh up whether I'm going to be doing it or not. Because it is handy to have just a power amplifier, so that you can actually input a preamplifier into it, and then you can actually test things like noise without having to go through an internal preamp. I could put a switch in to defeat the preamp, but yeah. That being basically putting the volume control up full and then feeding your preamp input into the inputs, and see if you've got any like loud hiss or something coming out of your preamp design, which means that it's crap. So I'll have a think about that later. I think all that hard work today deserves a nice cold beer. Cheers. See you in the morning. Well, good morning. It's the next day, and I've just spent the last about 2.5 hours, 3 hours, something like that, fixing up all the wiring. All these cables have been shortened. I've done the ground points already for each module. I haven't got the speaker ones on there or the earth from the mains plug, because the next point of contention is to actually drill the back panel, which I have just marked out. I also fixed the length of the audio lead for the left channel here, so it's now the right length. I've also fixed the LED. So, as I said, the next point of contention is to drill the back panel, which is just here. I've got a bit of ink over here, which might come off with a bit of isopropyl alcohol. So I've marked which way was up on this panel, so I remembered which way it is. The AC board's over here, the power plug input, which I've got a clamp somewhere. One of these, so they require an oval hole or elongated hole, and that's HP0716, and it's a packet of 4. So yeah, I'd need to first work out what the actual width of this thing is, so I know what size hole to drill. So I'll open the bag and get one out. Okay, so it's going to be a fairly wide hole. I think it's 12 or 13 from memory. I need my calipers where they buggered off to. Right here, there's so much junk on the desk now. Okay, so that is going to be 13.6, so a 14mm hole will be fine. And as for when it's elongated, how much it should be wide, it's going to be a lot wider than 14. So probably around about the 16 mark, maybe 17, no 16 I reckon. But basically I'm just going to file the hole out, which is going to take the most work, until the cable grip is in there and holds the cable tight, so it won't pop back out the hole. So so that needs to be center punched and drilled. I need to find my speaker socket, which is here in a complete mess. I just want to visually see. Yeah, it should line up. I did measure everything. It just means I'm going to need on here like a 6 to 8mm hole. I have insulated the terminals that come out, but I'll drill it first and then see and size it as necessary. So let me get to drilling this. I've already recharged my drill last night. So okay, so that one was going to be the hardest to do, but it is what it is. Alright, let's get to work. Success! A little time later, I've got it drilled and the core grip is in there. Just one problem. It's backwards. I've actually drilled this as if I'm looking at it from the top, because the transformer is on this side. I've drilled it if the power cord was to come in at the bottom on that side, so everything is reversed. But that's alright because I can just simply turn it up that way, so the power cord will come in at the top, which, okay, is probably, you know, not the best solution, but it's, you know, doable. The speaker socket's going to be upside down, but yeah, whatever. I also forgot to mark and drill the holes for the fuses that I was going to put in, so I've just tapped them in now. That ink did not come off very successfully, so that is that. So what I need to do now is assemble the rest of the panel and hot glue around some things that had the propensity to twist or pull out. So for a start, it's going to go up that way now. So I'm going to pass all the wiring for the speaker socket through the panel. This is a bit like play school. What's in the useful box today? And what's under the rocket clock today? So that will go in like that. I used 8mm holes for the wires to go through. That'll line up just fine, I think, and there's enough space to clear. The fuses, however, it just means that the piano keys will be at the top instead of the bottom where they were originally supposed to be, but whatever. So I'll get busy off camera assembling this, and I'll come back in just a minute. Right, a short time later, everything is mounted. So the first thing I'm going to do, I've got the glue gun warming up, so I want to go around things that have the potential to twist undone or come out. So the hot glue will prevent it from, or help prevent anyway, it from unscrewing. So what I want to do is I want to make sure that each of these, well, the grounds don't matter, but each one of these outputs is isolated from the chassis. So that's a good question. Right, so we've got continuity there. So if I go on the inside of the hole, there's no continuity there. That doesn't matter, that's the ground. There's no continuity. That's the ground also, doesn't matter. Okay, there's no continuity to the chassis, so, or the panel anyway, so that's fine. So there's nothing going to short circuit as soon as I plug it in or connect things to it. So these wires are going to get shortened and wired to the fuses. These will also get shortened and wired to the chassis. That mains earth should be long enough, and I might just leave the wires at their length or shorten them a little bit. So, okay, let's see if the glue gun is hot enough, which it is. So I'm just going to go right over the thread just to stop it from coming back out. Well, it's not going to stop it from coming out, but at least help prevent it from pulling out. Got a little bit in there, so it helps stop it from twisting around. I have to do the same sort of thing. I'll clean all this extra crap off a little bit later. I have to do the same thing to the front panel with things that have the propensity to twist undone. So I'll swap over panels, and I will do the same to the RCA sockets and around its thread. Alright, that should do that. Okay, now I'm going to put the thing back together in the case. Or actually, I might wire the fuses going to the speaker socket first. So I'm going to make each of these wires just long enough to go up to that point there. So it's going to be that long for that one, and about that long for that one. So I'll strip them back, solder them up, then I'll put the case back together, and then I'll work out what I'm doing next. Alright, got the sides and the back and the front back on. I haven't put the screws back in yet, but this is pretty much basically what it's going to look like. I've got the speaker terminal wires wired in now. Got to do the grounds yet, but that's fine. So I'm going to cable tie up the audio cables so that that just came completely unplugged. So they're at least somewhat tidy. And I'm doing a lot of this off camera because the video is already getting quite long as it is. We'd probably be close to the 50-minute mark now. So I don't really want to take too much footage of me screwing around, soldering wires and cutting things and etc. I've got to do the 6.3mm crimps for the AC power cord. The earth will reach to the chassis even though it's a bit stretched, but it'll reach If I untangle it a bit, it might probably be a bit better. So it'll reach. There's quite a bit of cable sticking out, but anyway. I've also got the header in there for the power transformer to connect to. I don't know if I mentioned that in the beginning, I probably didn't. So what I'm waiting on now is the transformer. So basically now I can go ahead, fix these grounds, fix these AC connections. The switch can probably be connected to the AC board again, as it doesn't need to come out anymore. I still think that these switch wires are way too long, but I'm going to go with it. So yeah, that's going to be stuff that I've got to fix up. I mean, I could probably cable tie the switch wiring to this top rail, which isn't really doing anything. And it'll clear the lid of the case anyway, so that's not a real great issue, but it will neaten up that wire and make it not appear as long. There'll be a bit of a loop at the end there, but that's fine. I'm not really worried about any of that right now. So I just want to make this as neat as possible. I mean, as neat as it's ever going to be. I mean, you're not going to really see the inside of this thing. It's basically, you know, hidden anyway, but aesthetically, when you're looking at the inside of the thing, it wants to look at least somewhat appealing, and that needs to tie to something. I'm not sure what yet, but you know, I might end up just putting cable tie down there, which should clear the transformer. I might put it on that one instead. Actually, I might do that now rather than talk about it. Let's do it. So I'll put it on that one down there, which just happened to fold over just like I wanted it to. And like that, because I want to keep these wires away from audio signal wires and stuff, because there's raw AC, well, slightly filtered AC by the 47 microfarad capacitor there. So I don't want it introducing any hum into anything else. So that should be fine. I can cable tie this end of the wire to the AC secondary wires that are coming in. Bob's your Auntie. Bing bang bong, we're done. Okay, that's going to be it for today. I hope you enjoyed this video. No, I'm only kidding. The next bit will be putting the transformer in, which, if I look at where this hole is, maybe too close to that that board over here, so I might be moving it more further down here, which is fine. As I said in the beginning, if I have to move it, I'll move it, and just leave the original hole there. It's fine, and I can get access to drilling on the underside. I do reckon though that it is going to be in the wrong place. Yeah, it happens, but anyway. Alright, just waiting on the transformer. Well, I would say good morning, but it's not. It is the next day, however, but it's actually mid-afternoon, actually 1 o'clock in the afternoon now. I didn't get this yesterday, as I was hoping. It came at about 5 to 1, so about 5 minutes ago. Oh, there's what it is. So let's check out the contents. One mounting bracket, 2 rubber donuts, a bolt and nut set. Yep, that looks like about a 5mm thread, so that's alright. I'll measure that in a second. And the power transformer. It's only an 80 VA, but it'll do the job that we need. So I'm going to just do a quick resistance check on the primary to make sure that A, it's intact, and B, that it still is not shorted or anything. So going to resistance, and I'll go across the active and neutral pins. And we have about 26 ohms there. That's not too bad. And across each secondary which is red and black is 1. So red, black. We have about 0.45 of an ohm. It's about right. And orange and white is the other secondary. There we go. About the same. Okay, so what I'm going to do is I'm going to crimp on the required crimps to connect it to the AC board, and then I'm just going to power the transformer up on the dim bulb and make sure everything is functional there. And we've got like roughly, we'll probably have about 15 volt either winding here, which is fine because the dim bulb will be limiting it. So let me get set about doing that and I'll be right back. Oh, I might just measure the diameter of this bolt so I know ahead of time. That's good enough. 5.5 roughly, so a 6mm hole should be more than enough. Okie dokie, let me get to crimping that. Alright, this is quite difficult to film because of where things are. I've got the transformer hooked up to the AC board. It's currently off. Insulated, and yes, I did cut off the tinned end of the wire first and stripped it back again before crimping to get a decent crimp. So don't anyone comment saying, oh, you shouldn't crimp to the solder joint or the tinned part. I didn't. So I'm going to put the meter somewhere down there where you can see it. I've got my tool here that holds circuit boards holding the two secondary windings apart from each other and also from each other themselves so we don't get any shorts. So I'll turn the supply on and dim bulb's not doing anything. So I'll measure across one secondary. There's something really not right with this meter. Yeah, okay. Alright, we've got about 19 volts there, according to this meter anyway. And 19 volts there, so it's not quite 18. It's a little higher than 18, which is still okay. I mean, the capacitors that I've got here are rated for 50 volt, and the ones bulk filtering on the PCBs here are rated for 63. And the other ones here are rated for 63, so it's not like it's going to blow anything up. So what I can do now is I can now crimp on the header to each secondary winding and then hook it up to the main board here and see if the relay engages for a start and basically what happens. But it will all be going through the dim bulb first, of course. Well, the transformer is in and that was a pain in the ass, mainly because the bolt is too short. I remember that with these transformers now. But I've got the secondary crimped. Yes, I cut the ends off and stripped them back and re-crimped them that way without crimping to the solder. The DC connections are currently disconnected. So I just want to see, and yes, I had to move the hole. I just want to see if this will power up without blowing shit up. And the relay just turned on. There was very little glow on the dim bulb. So we'll go into voltage DC and I'll first measure across the diode at the relay. About 7.4 volt. It's enough to pull it in. So what's at our DC connector? 51 volts with the dim bulb in circuit, so that's plus minus 20. Alright, and the LED is glowing. So I will connect up the DC supply connectors if I can so get a little bit of a discharge there. I don't know why, it's just bleeding off the caps, that's why. Right, so the amplifiers are now connected to the power supply. I'll just put my meter probes in the output socket. We've got no DC offset there, or about 0.5 of a millivolt. And if I measure at the other one, minus 0.1. Excellent. So I'll turn that off. Now that I know it's safe to plug directly into the wall, that is exactly what I'm going to do now. Right, it's plugged directly into the wall. Get my meter back in DC volts again. Nothing went bang. Excellent. I'm going to let it sit for a bit. Let's see what's across that diode now. It's still about 7 volts. And across the connector, still 50 volts. So we're getting plus minus 20 volts to the amplifiers at the end of the day, which is okay. So what I'm going to do now is turn it off. I'm going to load the amplifier into a dummy load and the oscilloscope, and we'll just see what power it outputs now at a slightly higher voltage. I reckon around about 5 watt. Alright, so the dummy load is hooked up to the amplifier on currently the right hand channel output, and it's currently turned on. So we'll just do a power measurement. Whoa. Shit. Just kidding. I learned from that video, I love inserting that in random places. I learned from the other video to actually film the device under test. So I'm going to crank it up, and I've got an output, and we're in clipping, and we're still clipping a little bit. I'm going to say about there probably. And that's what we see on the scope. In times 10 mode we've got 6.37 volt RMS. Almost dead on 5 watts. Excellent. Well, at least I've made an achievement. So I reckon into 4 we're going to have about 7, maybe 8. Let's find out. So I'll turn the volume down. I'll swap over the ground of the oscilloscope and the amplifier. Okay, wind it back up. Yes, we have an output. Clipping. Back it up till it doesn't clip. Which is about there. Which is 5.26 volt RMS. Almost 7, so not much of a difference. Okay, oh shit. So we know what its output power is. It's not even getting that warm, and it's been running at full power for about a couple of minutes now. But then it is going into the case here, so it's sinking the heat. So the next thing to do is to hook it up to the speakers and see how it sounds. That's about as good as I can get everything in shot. You can just see the TX speaker at the top there. I don't think you can quite see. Oh, you can quite see that one, yeah. Okay, so I'm going to move this chair out of the way. I'm going to turn the amplifier on. It's still currently got the oscillator going into it. I hear absolutely no noise. Nothing. Nothing except the faint background of the oscillator. Okay, so there's no mains buzz there. And it's coming out the right channel only. If I swap, without electrocuting myself, if I swap to the left hand channel, it's now coming out that one. Excellent. Alright, so what this means is that we can now hook in an audio signal and have a listen to how it sounds. Alright, I got an audio source now. It's a stupid song. I'm going to probably cut it down in editing. It's 5 minutes long. But I'll just play a little bit so you get the gist. So here we go.
I met this girl named Amy, dang she was fine. Walking through the cafe, saw her shine. With a smile so bright, she took my breath away. Invited her to dinner, gonna make my play. We wined and dined, laughter in the air. Every single moment got us lost in the flare. Romantic whispers, flickering candle lights. Here's to a memory we were about to ignite. Oh, bang that gong, Amy's got a dong, a crazy little twist in our love song. Thought it was a dream or maybe a play. Who would have guessed we'd end up this way? Oh, bang that gong, ain't nothing wrong, just a lively tune where we both belong.
Okay, that'll do for that. It's a stupid song, as I said. But it sounds alright, so I will play the one song that everyone was expecting. Okay, that'll do for a sound test. I'm quite happy with how that sounds, to be honest. I'm going to finish up putting it together and finalising it off camera. You don't need to see that part, it's just tidying the wiring up a bit and putting the lid on. So I'm going to leave this video here, and I hope you enjoyed watching it. And it was frustrating for me to do because of, one, the error I made with this bloody panel, and two, this stupid frickin' bolt in the transformer is too short. I don't know why they supply you a bolt which is not actually going to work properly, because they give you like 2 extra washers as well, so as well as a spring washer, if I could pick it up. So you get these 2 washers, which are, I want to say, about 1.5 mil thick each. So this goes on one end of the bolt. You pass the bolt through the chassis, then you put the transformer mounting gear on, and then you put this nut on, the washer on top, then the spring washer, and then the nut. There is no possible way you can do that. Not with the bolt length that you've got there. It's fucking impossible. Powertech really need to, sorry, Powertran really need to lift their game. So I didn't end up using those 2 washers, and I put the spring washer on the bottom because I was having so much trouble getting it on the nut to start from the top. There is a slight issue now that that bolt is about the same height as the feet. So it can, if it's one end slides off the desk, it can actually scrape the head of the bolt on the desk. But it does just clear it now. I can't really see it. Yeah, because when I was doing the bolt up anyway, it started pulling the lid, the bottom panel in a little bit and deforming it. Well, it's going to because it's not that thick. But anyway, I'm happy how that sounds. I mean, it does sound a bit shrill through the tweeters because, well, they're crap TX speakers. I mean, I don't expect hi-fi quality out of these crappy bookshelf speakers. But it'll do the purpose that it was intended for, which is for testing audio signals from CD players, tape decks, radios, whatever that I need an amplifier for so I can actually hear it. So anyway, I'm going to end this video here. If you enjoyed it, please go down below, like, comment, and subscribe if you haven't done so already. And as always, this is the Astro30 saying, see ya, thanks for watching, and I'll see you in the next one. Not sure what that will be, but we'll soon find out. Cheers, bye.
Amp it up, let the music flow. Ale's got the magic, come and see the show. Experimenting with wires, making sound divine. When things blow up, we just laugh, that's fine.